Dynamite! Dynamite!
Hey, how you doing? My name's Hero. This is Coding with Strangers. I want to talk about something that was interesting me yesterday, and that was the fact that we have a AI bot called Devin now, right? And Devin is being used to really replace software engineers. But a closer look into the benchmarks and the capabilities of it really presents a situation where it probably isn't going to be able to keep up or do the things it wants to. But the thing that you need to constantly remember with AI and machine learning is the current version of it is always going to be the worst version of it. I remember a long time ago when AI photos were being totally decimated by just human beings eating spaghetti. It's starting to get a better hold of people eating spaghetti, and I think that should be the benchmark moving forward. Like, if we're ever talking about is AI getting better, can your AI create a human being, specifically Will Smith, eating spaghetti correctly? And if it can't, the AI is trash. But with all the effort and energy that goes into creating AI works, we have to beg the question, what are the consequences and repercussions of this work? And this article I found popped up 8 days ago, and it kind of vibed in what I thought it would be. I read this a few days ago. Amid explosive demand, America is running out of power. And the gist of this, I'll put the link in the chat below and also in the video below. But basically what it's saying is a vast majority of the energy that we're using to make AI generate isn't doing us any favors on the grid. Vast swaths of the United States are at risk of running short of power as electricity-hungry data centers and clean technology factories proliferate around the country, leaving utilities and regulatory grasping for credible plans to expand the nation's creaking power grid. Now, if you guys know anything about America's power grid, it hasn't been updated since the 1950s. And we have two separate grids. We have the grid that sustains energy for 49 other of the states, I think 48, probably 47, because Hawaii and Alaska are separated off that grid. And then we have Texas, who has its own grid. Texas 3 years ago, I believe 2019, experienced one of the worst power grid failures and led to a few people dying, 238 dying during a winter storm. Our grid is barely capable of maintaining and handling what we request of it as just normal people. Since 2017, California as a state has been experiencing rolling blackouts during peak usage hours. So what happens when the power consumption increases? And where are we going to get it? Where does the infrastructure come into play? In Georgia, demands for industrial power is surging to record highs, with the projection of new electricity use for the next decade now 17 times what it was only recently. Arizona Public Service, the largest utility in the states, is also struggling to keep up, projecting it will be out of transmission capacity before the end of the decade, absent major upgrades. So this is interesting on two levels. North Virginia needs an equivalent of several large nuclear power plants to serve as new data centers. Plans are under construction. Texas electricity shortage already routine on hot summer days face the same dilemma. The soaring demand is touching off a scramble to try and squeeze more juice out of an aging power grid while pushing commercial customers to go to extraordinary lengths to lock down energy sources, such as building their own power plant. Could you imagine cities building their own power plants? Wouldn't be a bad idea. When you look at the number of staggering when you look at it, it's staggering, said Jason Shaw, chairman of Georgia's Public Service Commission, which regulates electricity. It makes you scratch your head and wonder how we ended up in this situation. How were the projections that far off? This has created a challenge like we have never seen before. So the projections for the number of energy earning demands in North America has doubled. 9 years of growth forecasted demands for new electricity in gigawatts per hour. So you can see throughout the course of the time, and this is based on the California, Mexico, Canada Data Cover Center, and this is sourced from the North American Electricity Reliability Corporation Long-Term Reliability Assessment in 2017, and just how it has incremented. But there was a massive explosion between 2022 and 2023 when AI was announced. And these data centers, these cloud-based infrastructures that are going to be used to help generate and cause the power growth that these systems need are going to be coming from, are going to be crushing basically these systems. And I know what you're like. The thing that immediately comes to my mind is like, is this all just, is this all just AI? No, I believe that there's also room to believe that in early 2021, this significant bump you see here comes from the NFT and the Bitcoin bros. But because this was quickly sought out as a failure and not something that was realistic, things returned to normal quite quickly when Bitcoin dropped below standard. Even though it's having sort of a boom right now, please don't buy into it. It's just hype. They're going to make you hold the bag. There's no such thing as diamond hands. So is AI so this also gives me two indications. One, if there's an AI stock out there or an AI based company, Nvidia, for example, you might want to invest because money talks, bullshit walks. And basically, when the Bitcoin boom happened, not too many companies bought into that, even though everyone had a minted coin, which is nonsense. But there is backing to support because money is supporting, because power is supporting. These systems will need infrastructures to base it out. But the question is, and the problem is, our infrastructure is out of date. We don't have enough to sustain just ourselves. So what do we do? Furthermore, what do you do to help protect yourself? If you do have a home and you haven't already started looking into solar energy or solar panels, I don't know what's stopping you. It's got to be to take $50, $120 off your account, or to even be able to then sell that energy back to the grid for credit. It has to be a benefit that you are interested in acquiring. Secondly, we need to better optimize AI. AI in its current form is very brash and very unruly. What do I mean by this? For example, there's a lack of optimization when it's quantum computing, because when you have a situation where these systems are trying to work, they are trying to work through a plethora of different scenarios and options, some very extreme, some not extreme, while the answer is somewhere in the middle. If this was a normal person answering the question, if you asked me 2 plus 2 is, I wouldn't have to delegate what is the value of 2. As a human, I can delegate, therefore conserving my energy and making more pointed decisions to keep me in the narrow, thus using less energy. But because the span of AI knowledge has to walk every possible route, you can have a situation where you'll go through 10,000 random options, I'm being facetious, just to come to the same simple conclusion a normal person was. The question that a lot of people are going to be terrified of answering is not so much as AI, can AI do the job, but do we have enough energy for AIs to do the job? And also, these companies we know don't pay their fair share in electric bills, because a lot of these companies come to these cities and towns with the expectation of getting deductions for their building being there. For example, a lot of Walmarts and a lot of if you have a major company in your area, they probably get their water, their electricity, their waste all discounted heavily by the city because their supposed ability to bring in business. Is that going to warrant enough of a is that going to warrant enough of a situation to make them stay, or to make them start paying their fair share? These are all things that we're going to have to think about and consider heavily as we take a look into this. I want to look at one more article. The surge in AI is straining the U.S. power grid. Artificial intelligence is not only driving stock prices of chip companies to new heights, it's also pushing demand for energy significantly higher than anyone was anticipating. The chip requirement and increase is also very terrifying because we know that chip manufacturing happens far out on the east, and we're underserved and under-delivered. Could our ability to maintain power, strength, or authority in the world of the eyes in the eyes of the world come from our ability to compute and navigate information? If we can't do that, I don't know if that's something that would tilt the scales. I think nuclear capability will always do that, and that's also another option we have, is to introduce nuclear power. But how many of us want to have? I think Chernobyl is a scary thing for a lot of people, and seeing as how, decades after it's happened, there's still no sign of going back, right? That's still something people very much hold on to in fear. The 9-year projection growth forecast for North America has essentially doubled from where it stood last year as companies begin to construct on AI hosting facilities that make the demand for traditional data centers look minuscule. Last year, the 5-year forecast for grid strategies projected growth of 2.6. The number has since nearly doubled to 4.7. The planner expects a peak demand growing at 38 gigawatts. Hey, how much do you need to go back into the future? Or go back into the past? Or go into the future? A bit more than the total number of housing units in Texas. Damn. 1.7 million homes. 12.7 million homes. So we would basically be putting the equivalent of the state of Texas homes on top of what we already have. And Texas can't handle itself. We're screwed, y'all. Fast forward to an annual peak demand growth forecast appears ahead of growth rates. There are double or even triple those of the recent years. Grid strategies, road transmission planners need long-term forecasts for both electricity demands and sources of electricity supply to ensure sufficient transmission will be available when and where it is needed. Such failure of planning could have real consequences for investment, jobs, systems, reliability for electric customers. So what do we take from here, boys and girls? One, we need to start planning more efficiently, and we need to make sure that our governments, we make sure our local politics, if you vote in your current area or district, these are topics that are being brought up. I don't believe energy consumption and energy growth will be strictly relegated to just being done by our systems and our system managements. I think that this is going to become something that people very much so do in a community base. I could see small communities building out power plants for their community as they can't rely on the grid heavily. What does this mean for taxes? What does this mean for people paying? What does this mean for what does this mean in general? How do you protect yourself? Like I said, I think you should have a conscious mindset to have solar involved in any housing plans you do moving forward. But ultimately, we want to try and capitalize on this. So I'll definitely be making notes of, companies that will be investing in power supply. LP&G is one of my favorite. But, if you want to keep up with me and you wanted me to do a story on what stocks, what companies are going to probably be building the infrastructure that's going to be needed to keep AI generating at such a powerful flow, feel free to like, share, and subscribe at the bottom. Once again, I appreciate y'all kicking it with me. This has been Coding with Strangers. My name's Hero. Peace. Okay, clap it. Throw a little bit of fire in there.
Get down.
Nah, why haven't you sent me... Nan, have you sent me a message on Discord yet? Because if you haven't, I'm going to kick you out of my chat. If you haven't, I'm going to kick you out of the chat.